This recording is the review questions for chapter 13 of chemistry. And I'm going to start with question number 6. And question number 6 says that glass has a specific heat capacity of 0.840 joules over grams times degrees centigrade. And then it tells us that magnesium, solid magnesium, has a specific heat capacity of 1.020 joules per gram degree C. And silver, solid silver, has a specific heat capacity of 0.240 joules over grams degrees C. And so then it says if I add equal amounts of heat to equal masses of these substances, and they all start at the same initial temperature, which one will get the warmest and which one will stay the coolest? So to answer this question, you have to remember that specific heat capacity is the amount of heat that it takes to raise the temperature of 1 gram of the substance 1 degree centigrade. So how much heat does it take to raise how much energy does it take to raise 1 gram of the substance 1 degree centigrade? So so if we look at silver only takes 0.240 joules to raise the temperature 1 degree centigrade. Magnesium takes 1.020, so it takes much more energy to raise the temperature of a gram of magnesium 1 degree Celsius than it does for silver, because silver has a lower specific heat capacity. So if you apply the same amount of energy to each of these, the one with the lowest heat capacity will have the greatest change in temperature. So in other words, the lower the heat capacity, the easier it is to heat up that substance. So this will have the greatest heat capacity, the greatest change in temperature. And then conversely, the one that has the highest heat capacity will have the least change in temperature. So least delta T, change in temperature. You might remember in class that we said that water has a high heat capacity compared to many substances. So water is 4.184 joules over grams degrees C. And what that means is that water resists changes in temperature. So we said that that's especially important for large bodies of water like the ocean, because even though the temperature, the air temperature may change a lot, the water temperature doesn't change that drastically because it has a high specific heat capacity. Okay, let's go ahead and do number 8 then. Okay, so number 8 says we have a 2.5 kilogram sample of copper, and we are told that the specific heat for copper is 0.3 386 joules over grams degrees C. And it says that that copper starts out at a temperature of 24.1 degrees C, and it experiences a change in temperature to 19.7 degrees C. So this would be T initial, the temperature that it starts out as. This would be T final. And then it says how much energy was involved and did the copper gain or lose energy. So our equation for energy is Q equals mc delta T. So Q stands for energy, M stands for mass, C is specific heat capacity, and delta T is the change in temperature. So it says how much energy was involved. So in other words, we're being asked to solve for Q. We're given the mass, 2.5 kilograms. We're given C, and we're given the initial and final temperature, so we can calculate delta T. So delta T is T final minus T initial. So that's going to be 19.7 minus 24.1 degrees C. So delta T is negative 4.4. Okay, so it's negative because the temperature decreased. Started at 24 and went down to 19. Okay, then the only other thing you have to realize is the units for specific heat are joules per gram per degree C. So therefore, the mass needs to be in those same units. So we need to convert this 2.5 kilograms to grams. So 2.5 kilograms, there are 1,000 grams in a kilogram. So this will be 2,500 grams. Okay, so now we have everything that we need to plug into the equation. So Q is equal to 2,500 grams times C, which is 0.386 joules over grams degrees C. And then delta T we determined was negative 4.4 degrees C. Okay, so Q, if we do that calculation, Q will come out to negative, so we have two positives times a negative, so it's going to be a negative number, negative 4,246. And if we look at units, these grams will cancel, degrees C canceled, you're left with joules, and that is the proper unit for energy. So our units would be joules. This limits us to two significant figures. So that means that we would have to go 4,200 joules, and it's negative. And then it also asks, did it gain heat or did it lose heat? Well, if the energy is negative, that means that it lost heat. Let me go back and say one thing about significant figures here with delta T. So remember, when you're adding or subtracting, you don't count significant figures, you look at place value. So since each of these temperatures went out to the 1/10, then when we do the subtraction, it also goes out to tenths. So that's how we got the negative 4.4. Okay, so that's number 8. Okay, number 9 says that we have 500 grams of water. and it says the water is in its liquid phase, and it says it loses 5,892 joules of heat. If it started out at a temperature of 25.0 degrees C, so that it says it started out at that temperature, so that you should realize that's the initial temperature. What is its final temperature? So we are asked to find T final. Okay, so a couple things to point out here. First of all, it says it loses this amount of energy, or it loses that amount of heat. So if it loses it, that means that's going to be negative. So Q is equal to MC delta T. Okay, so we know that this is the energy. So Q is equal to this amount negative. And then we're asked to find the final temperature. So we know the mass, we're given the mass. This particular question did not give you C, but you would be given that on the test, or you can look it up in your book. So C for water is equal to 4.184 joules over grams degrees C. Okay, so we know this, we know mass, we know C. So we can't calculate T final directly, but if we calculate delta T, since we know T initial, we can then calculate delta T. So let's solve this equation for delta T. We're just going to divide out the M and the C. So Q divided by MC will equal delta T. Okay, so that Q is going to be negative, remember, so negative 5,892 joules divided by the mass, 500 grams, and then divided by C, which is 4.184 joules over grams degrees C. So if you do that math, it looks like we can have 4 significant figures, so it will be negative, because you have a negative on top and positives on the bottom. So it would be negative 2.859. And if we look at units, well, first we're calculating delta T, so that tells you that it's going to be degrees C. But if you need to look at units, we have a gram here and a gram here that'll cancel, a joule there and a joule there, so we have degrees C left. Okay, so this is delta T. Now that we have delta T, we can use the initial temperature to calculate the final temperature. So delta T, so TF minus TI is equal to delta T. So we want to know TF, so we just add TI to both sides to get rid of it on one side. So TF equals delta T plus TI. So delta T we calculated as negative 2.859 degrees C, and we were given TI as 25.0 degrees C. Okay, so negative 2.589 plus 25 degrees C, then TF will be equal to 22 And we're going to be limited here now just to tenths because we're adding, so we have to look at place value. So TF will be equal to 22.1 degrees C. Okay, so that was number 9. And number 10 is going to, actually, well, I guess that chapter 10 is still, or number 10 is still an energy equation. So number 10 says that we have 175.0 grams, so it's going to be the mass, of an unknown metal. And it says it gains 5.6 kilojoules of heat. The metal's temperature rises from, so if it rises from 24.3 degrees C, that tells you that's going to be the initial temperature, to 110.5 degrees C, so that's the final temperature. What is the specific heat capacity of the metal in joules over grams degrees C? Okay, so same equation. Q equals MC delta T. Okay, so this says it gains this much heat. So that means Q is going to be positive. We are given the mass. We have the information that we can use to calculate delta T, and we are asked to find the specific heat. So we just solve this equation so that we're solving for C. Just divide out the M and the delta T. So on both sides. So Q divided by M delta T will equal C. Okay, so let's go ahead and calculate delta T. So delta T is equal to TF minus TI. So it's 110.5 degrees C minus 24.3 degrees C. So delta T is equal to 86.2 degrees C. And again, because we're adding and subtracting, we're bound by place value, so we go out to the tenths place. Okay, so Q, it says it gains 5.6 kilojoules. Okay, so again, you have to remember that specific heat capacity is in joules, so we've got to change these kilojoules to joules. There are 1,000 joules per kilojoule. Okay, so kilojoules are going to cancel. You'll be left with joules, so it's 5,600 joules. Okay, so that's going to be Q. Let me go ahead and move this up here. Okay, so the Q is 5,600 joules. The mass that we are given is 175.0 grams. And then we calculate delta T here as 86.2 degrees C. Okay, so notice none of the units are going to cancel, and that's good because the units for specific heat capacity are joules over grams degrees C. So if we do that math, you will end up with 0.2995 no, sorry, no. wrong answer. You'll end up, if you do that, you will end up with 0.371 joules over grams degrees C. That's what the specific heat capacity for this unknown metal will be. We can have three significant figures. Actually, I guess technically we only have two, so I guess we'd have to go 0.37. So get rid of that one. This 5600 here lines us to two significant figures, so it could be 0.37 joules over grams degrees C. Okay, 11 and 12, we'll skip those for now. Number 13, in a calorimetry experiment, what two things start off at the same temperature? And that the answer to that would be the calorimeter, the water start off at the same temperature. They would have the same initial temperature. And what three things end up at the same temperature? So remember, in a calorimetry experiment, you are dropping the initial temperature of the water is measured, and then a hot object is placed into the liquid in the calorimeter, and that hot object will transfer energy to the water, and that's going to warm the water. And as the water warms, the object's going to cool down so that the water temperature will increase and the temperature of the object will decrease. And when they get to the same point, so when the water and the object get to the same temperature, that's the end point of the experiment for calorimetry. So the question asks, what three objects would be the same temperature at the end of the experiment? So the answers would be the water, the object, that the hot object is no longer hot, that was dropped in, and then thirdly, the calorimeter. But in our calculations, we're ignoring the calorimeter. So our endpoint for calorimetry is when the water and the object reach the same temperature. Okay, let's do number 14. So 14 is our first calorimetry problem. So a calorimetry experiment is performed on a sample of metal that is 112 grams. We're not told what the metal is. It is heated to a temperature of 175.0 degrees C. So that would be Ti. So that's the initial temperature for the metal. And then, so this is the metal, the piece of metal that's going to be dropped into the calorimeter. Then it says that the calorimeter contains 250.0 grams of water. And it says the water temperature rises from 27.1 to 31.7 degrees C. So it rises from this to this. So this is T initial for the water. This is T final for the water. Okay, so let's go ahead and calculate delta T for the water. So it would be TF minus TI. So 31.7 minus 27.1. So delta T is equal to, for the water, 4.6 degrees C. So if you think about it, that hot object dropped into the water is going to increase the water temperature. And now the other thing we said was that the end point for calorimetry is when the water and the object, the metal, reach the same temperature. So that means this is also the final temperature for the object, for the metal. So this would be T final for both the water and the piece of metal. Okay, so then it says, what is the specific heat capacity of the metal? Okay, so remember that we're ignoring, and this problem tells you to ignore the calorimetry. So, or ignore the calorimeter. So that means that negative Q equals Q. So this means that the heat lost by the object is gained by the water. So you get that transfer of heat from the object to the water. So we know that Q is equal to MC delta T. And this is negative Q. So it's negative MC delta T equals MC delta T. Okay, and so this is all for the metal. This is the metal. This is the water in the calorimeter. So what we are asked to find is what is the specific heat capacity of the metal. So this is the variable we're asked to find. So I'm just going to multiply out the M and the delta T from this equation. So that means we will have negative C is equal to MC delta T. So that's all this here. So remember, this is for the water. And then that's what we had to divide out. We had to divide out the M and the delta T for the metal. So this is M delta T for the metal. Okay, so that's the equation that we have to work with. Now let's just plug in numbers. So the top's the water, the bottom is the metal. So the mass of the water was 250 grams. The C of water, you'll be given this. You could also look it up in your book, 4.184 joules over grams degrees C. And the delta T for water we calculated as 4.6 degrees C. Okay, then we're going to divide that by the mass of the metal, which was 112.1 grams, and then delta T for the metal would be TF minus TI. So I'm going to go ahead and erase this so I can, so for the metal, the delta T for the metal will be T final 31.7 minus 175.0 degrees C. And so that is negative 143.3 degrees C. Okay, so I'm going to put that in here. Delta T for the metal, negative 143.3 degrees C. Okay, so this is negative C is equal to all of that. Okay, so I'm just going to go ahead and erase this so we have them down here. Just do the calculation. So negative C is equal to, so we have all positives on the top and we have one negative on the bottom, so our answer is going to be negative. And what you will get is that negative C is equal to negative 0.2995 And if we look at units, these grams will cancel. These degrees C will cancel. So you're going to be left with joules over grams degrees C. And that's the units that we have, that we use for a specific heat. So it's going to be joules over grams degrees C. Okay, so if negative C is equal to negative, then C is equal to positive. So all you do is switch the signs there. 2.92995 joules over grams degrees C. If we look at significant figures, we can only have 2. So this would become 0.30 joules over grams degrees C. Okay, then the last one that we will do for this chapter is number 15. And number 15 says we have a 145.1 gram sample of tin. And it tells us that tin has a specific heat capacity of 0.210 joules over grams degrees C. And it says that it is heated to 150.0 degrees C. Okay, so that if the tin is heated to that temperature before it's dropped in, that is the tin's initial temperature. Then it says it's dropped into a calorimeter that we don't know its mass, but the water starts out at a temperature. So if it starts out at that temperature, that's TI, is 22.6 degrees C. And it ends at 30 degrees C, so that's TF. And remember that the end point for calorimetry is when the water and the object, in this case tin, reach the same temperature. So whatever the final temperature of the water, that will also be the final temperature of the tin. Okay, and then it says, what is the mass of the water? Okay, so again, negative Q is equal to Q. The energy lost by the metal will be gained by the water. So it's going to be negative MC delta T equals MC delta T. So this is for the tin. This is for the water. Okay, we are asked to find the mass of the water. Okay, so all I'm going to do is divide out that C and the delta T on both sides. Okay, so now the mass of the water okay, so this top portion is for the tin. The bottom portion is for the water. Okay, so negative, the mass of the tin was 145.1 grams. The C for tin we are given as 0.210 joules over grams degrees C. And then delta T for the tin will be TF minus TI. So it's going to be 30 minus 150, which would be negative 120. And we go out to the tens place since we're adding and we're subtracting. 120.0 degrees C will be delta T for the tin. Then we're going to divide that by C, so these bottom is for the water. C for water, you'll be given 4.184 joules over grams degrees C. And then delta T for water, it's TF minus TI. So it's 30 minus 22.6. Okay, so that's going to be a positive number because the water is going to heat up. So TF for the water is 7.4 degrees C. And all of that's going to equal the mass of the water. So let's look at units first. So here we have joules over grams per degree C here on top and bottom, so they cancel. Here we have degrees C and we have degrees C, so they cancel. So all we're left with is grams, and that that's a mass unit. That's what we measure mass in. Okay, so then if we look here, we have a negative here, and we have a negative here. Negative times negative is positive. So the top is going to be positive, the bottom will be positive, so the mass of the water will be positive. We can't have a negative mass. So the mass of the water negative 145.1 times 0.120 times negative 120.0 divided by 4.184 divided by 7.4, and you will get 118.09854 grams for the mass of the water, but we can have just two significant figures, so that would mean we'd have to go with 120 grams is equal to the mass of the water. Okay, so those are the kinds of problems that you need to be able to do for module or chapter 13.